I'd like to finish up this section or this chapter on separate compilation units and namespaces with an example. And in this example, there's going to be one main program, the very simple main, and it's going to use two classes, A and B. They're going to be in one namespace. Try to keep it a little bit simple, but this does involve namespaces. So let's take a look at these two classes. I'll need a a.h file for the class A. And what I've done is I used the wizard in Eclipse to set this up. And so when I set up this class, I asked for a namespace, space1, so sp1. And so we have a class A, very simple class, constructor, destructor, and it's got a data member that's an instance of another class, class B. And I'm also going to create an instance of class B in the main function as well. All right, so a.h looks like that, very simple. Class A has a data member, which is object of, that's an instance of class B. The CPP file looks also very simple. Of course, it needs to include the a.h file where the class is declared and defined. And then let's move on to b.h. So b.h is the second class. Now class B is it's even simpler. It's just a class B with a constructor, a destructor, no data members, and we'll put in some data members soon. And so the corresponding CPP file looks like that. It has you have to include b.h in the CPP file, constructor, destructor. That's it. Nice and simple. All right. So now all of this works. You can compile this. Okay, so everything worked. I was able to compile a.cpp, I was able to compile b.cpp, and then main.cpp. Alright, so 3 separate units. Actually, with counting the header files, it's a total of 5 files. Alright, so now let's take a look at what happens if we were to change a.h, and let's say we have this private B data member, and to be able to use B, you need this. So if you were to comment this out, you would get an error message basically saying that, well, it doesn't know what B is. So you definitely do need to include b.h. Okay, so that's definitely needed. Without that, you would get an error message. All right, so now A depends on B. That is, A is a client of the B class. And now let's see what would happen if we now have B depend back on A. So it turns out it doesn't make sense in C++ to have a data member that is strictly an instance of class B. That's a statically allocated object. So something like this would make sense in Java. In Java, this would be fine because of the way memory is allocated. We know that everything is a reference in Java. So when I'm switching back and forth, pretending this is Java, this would be okay. However, this is C++, this is not okay. If we were to look at how we did things in a.h, to have this data member B, we needed this, right? We just saw that in the last step. If you comment it out, we have problems. What happens if you try to do this? Well, it turns out there really isn't a way to do this. We can try, we can say include a.h. But notice, remember, that these includes are very dumb. All they do is take the contents of this file a.h and put it into wherever you do the include. So let me try to put this side by side. There you go. So now we can compare them. Here's our b.h, and here is our a.h. They look very similar. Right now. Right, I'm not able to. Okay, there we go. Okay, oops, I put this in the wrong space. You don't want to do this here. Because we are defining, because we use a namespace, you want this to be outside as we have it in a.h. So you would think that this should make sense, that when you say to use b as a data member in a, we had to pound include b.h, and to use a, you would think you could do this. Well, it turns out, as if you remember, this just pound includes all of this file into here. Well, in this file we're saying we're going to include all of this file into here. So of course that's not going to work. This is the kind of recursive pound includes that that these things are meant to prevent. So this, it turns out, without these, you can try this out. I'm not going to do it now, but you can try this out. Without these pound if and defs, this would give you an infinite recursion. That is, this file a.h is trying to include b.h, and b.h is trying to include a.h. So try it out without the pound if defs. This will not work, and it's not because of the pound includes. It's because we're saying that each object A will have a statically allocated object B. Each object B will have a statically allocated object A. That just doesn't make sense. However, what does make sense is to have a pointer. Once you do this, this is a very different thing, because a pointer is just a 32-bit or a 4-byte quantity. So the C++ compiler will know exactly how much space to allocate. It's only as much room as a pointer on a 32-bit system. It's just 4 bytes. So now it doesn't have to worry about how big A is. All it's going to save here is a pointer. Before, if we didn't have this, we would need a complete A object. Well, A objects have a B object inside them, and then B objects have an A object inside that. That's recursive, so that won't work. However, this does work. Let's try this out. All right, let's compile this, and we have some problems. All right. Okay, so it turns out this will work, except that we don't want to pound include a.h here. But we do need to say what kind of a thing A is. And to do that, what we have to do is to use what's called a forward declaration. And so here's how we would do this. We say class A. Okay, so now we are saying that A is a class. We don't have to actually do the pound include a.h. I think we might be able to, but I think it's better to take that out just because it doesn't really actually do anything and it might cause problems. So let's try this. I think this is the way to go. Okay, we're all set. So this will work. So there are some differences. In a.h, for class A, we're going to set up a data member that's an instance, that's an object of type B, so we have to pound include b.h. In B, we're going to have a pointer to A, and all we have to do is say that A is a class. Now I think if we put this back in, say something like pound, first of all, it's going to cause problems. You can think about this, just the only thing you have to remember is that whenever you do a pound include, you're going to take everything that's in a.h and just put it over here. Of course, if it's already been defined, then you don't do it, right? Because you only do it basically if a_h_ has not been defined. if it's not been defined, then you define it and then you include all this stuff. Okay, so it takes a little bit of working your way through, but it's once you do it a few times, it'll make sense. So let me save this. I hadn't saved it before I compiled it, and let me see if this still doesn't like it. So all right, I'm going to take this out because I don't need it. So if you want to have these interdependencies, you do have to come up with this kind of a dependence. In one of them, you will need to pound include. In the other one, you don't. And at first, it looks kind of odd, but actually, this is how you want to do it. Okay, so here's a nice example. And so in a separate compilation unit, let's say wherever main is, you can still use all of this. You can use A, you can use B, you can pound include A, you can pound include B. There's no problems with that. And you might want to work through why this works. Remember that when you do pound include A.H, you're taking all of this, putting it into here. So right over here is, you can think that everything in A.H is put in there. Now one of the things that's done is in A.H you get a B.H. So in effect, what you're doing is you're actually taking all of this and putting it into here, and then taking all of this and putting it into here. So essentially it tells us that we really don't need this. Let's try this out. Comment this out, and all of this should work now. Since we reorganized our code from where we started, we don't need this anymore. Okay. Why is that? Because, and what you would say, well, wait a minute, how do we know what B is? Because we're only including this class. Well, notice that we are actually doing a pound include B.H. Okay, and then A.CPP only has to include A.H. Even if you do something with B here, you're okay because you have pound included here. Same thing with B.CPP. B.CPP says we have to include B.H, and inside B.H we actually do forward declare A, and so this is okay. So it's possible that if you wanted to actually do something with A.H, once we actually start writing code, we probably will need to pound include A.H. Okay, and now let's compile this. This works, and then this is getting kind of, oops. Notice A.H includes B.H, so there's some redundancy here. That is, basically, we should be able to remove this and still get it to compile. All right, so the final step would be to simplify some of the pound includes. Not that it makes any difference, because as long as you use the if and ifs, you are certain to avoid recursive pound includes. So the final setup that we'll have is in B.CPP, you don't even need to pound include B.H. You just include A.H, and everything, since A.H includes B.H, everything is included, and there's no recursion. So work your way through an example like this. You can go back, start from scratch, and set this up yourself. It's very instructive. It tells you, it'll tell you a lot about how pound includes work, and you can think about it. Try different things. For example, try making this not a pointer but an actual A object. It won't make sense. Shouldn't make sense. You should not be able to do it. And then we haven't talked about inheritance. Try this. Try saying in using inheritance, have class B inherit from class A, or the other way around. These are all nice things to try out with pound includes and dependencies between classes. So definitely a good thing to try out.